All right. So here's another video, kind of reviewing something that that was taught before, maybe in your Algebra 1 class last year, or maybe in your middle school class. But it's called simplifying square roots or radicals. Sometimes I tend to say square roots a lot, right? You never hear me say radicals in class, but sometimes in the book or maybe on tests or something like that, you might hear radicals. These two mean the same thing, okay? Square root. This symbol, you can call it a square root. Oops, square root. You can call it a root or you can call it a radical. It's all the same, okay? So here, we want to simplify the radical to the simplest form. So how do we do that? I'm going to show you two different ways. Okay, so maybe I taught you one way in class, but I want you to know both ways because both ways are very useful. But where am I going to do this? Let's try this out. So the first method, you have to understand what it means to be a perfect square, right? A perfect square. So what I mean by that, so 1 squared here, and you don't have to write this down right now. Just kind of look at what I'm writing and just understand. This 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. All right. So all of these numbers, the ones highlighted in red, there you go. All of these numbers are called perfect squares. Okay, they're called perfect squares. Why are they called perfect squares? Because when you do the opposite, when you square root these numbers, right? When you square root these numbers, when you go square root of 1, you're going to get 1 back. Square root of 4, you're going to get 2 back. Square root of 9, you're going to get 3. Square root of 16, 4. Square root of 25, 5. Square root of 36, 6. Square root of 49, 7. Square root of 64, 8. Square root of 81, 9. And then square root of 100 gets you 10. Right? So, and it keeps going, right? 11 squared is 121. 12 squared is 144. So you could keep going. But I'm just going to stop at 10. So the first method is we're looking at, so all of these are perfect squares. So the first method is, let's look at this number 75, right? Let me do the work here. I'm going to start the work here. Okay, so I'm going to come back to this. I'm going to keep referring to this. So let's look at the number 75. We're going to ask ourselves, can we split up 75? What are some factors of 75? There's 1 times 75, right? There's 2 times something. Does it get a 75? I don't think so. Let's see. What about 75 divided by 3? That works, right? 3 times 25 is going to get you 75. What else? 4? No, 5 times 15 is going to get you 75. 75 divided by 6, that gets us a decimal. 75 divided by 7, that gets us a decimal. 75 divided by 8, that gets us a decimal. So you just got to figure out what the factors of 75 are. Let's just stop here, though. Right? When I see a perfect square, I'm going to use those pairs as my factors of 75. So right here, I see 25 is a perfect square, right? And I have 25 here. So what I'm going to do is I'm going to rewrite my square root as 25 times 3. Square root of 75 is the same thing as square root of 25 times 3. And then once you do that, you can split up your square roots like that. And then square root of 25 turns into 5, right? Square root of 25 turns into 5. So that's going to be 5 square root of 3, and that's it. Okay, that's it. So that's how you solve or simplify this to the simplest form. Okay, so that's one way to do this problem. Let me show you the other way to do this problem, but I'm going to do it for number 2. Okay, I'm going to do it for number 2. It's the same thing. It's the same thing, though. And maybe this one's easier, right? Maybe this one's easier. So let's try this one out. So another way you can approach this is just breaking down that number 45, right? Break it down into 2 different factors. What are 2 numbers that you can multiply to get your 45? Immediately, I'm already thinking 5 times 15, right? 5 and 15. Okay, can I break down 5 even more? No. So I'm going to stop there. What about 15? Can I break it down? Yes, I can. That's going to be 3 times 5, right? And then can I break these up even more? No, I can't. So I'm going to just keep it that way. So what this means is, oh, see, I already made a mistake. Sorry, this should have been 3. Oops, that should have been 3. 3 times 15. Okay. So what this means is these are our prime factors of 45. So what I'm going to do is square root of 45 is the same thing as 3 times 3 times 5. You're multiplying all of those numbers together. Let me do that in red, actually. 3 times 5. Right? So from here, I want to start pairing them up. If I could pair up some of the numbers, let's pair them up together. And so what do I mean by that? 3 times 3 is the same thing as 3 squared, so I'm pairing that up. Times 5. Okay? Now you can split these up. Whatever you're squaring under the same, whatever numbers you're multiplying under the same square root, you can split them up like this, right? And then remember, square root and square is they're opposites of each other, so they just cancel out, and you get 3 square root of 5. Okay, 3 square root of 5. If you use the other method here, right, this method, let's try it out. So square root of 45, I'm asking myself, what factors of 45 have a perfect square? So I'm trying to look at these numbers here and see if any of these numbers can go into 45. And immediately, I'm already looking at 9, right? Because I see 9 times what is 45? Right? If you're thinking 5, good job, right? You could also do 45 divided by 9 to get 5. So I know 9 is going to be one of my factors that'll help me. So I can split up 45 into 9 times 5. And then I specifically chose 9 because when I split it up like this, it's going to be 3 square root 5. Right? So either way it works. Whatever works for you. Whatever is the easiest for you, right? But I'm not going to keep doing 2 methods for you guys. This is method 1, method 2. Maybe I'll switch around. Okay. So let's keep going. Let me do number 3. Let me do number 3 with method 2 or method 1. Okay. So let me split this up. I know 180 is 2 times 90. Right? And I could keep going. 90 is 2 times 45. Let me keep going. 45 is, again, 5 times 9. Right? We did that up here. And then I could keep going too. 9 is 3 times 3. Right? So let me stop there. I don't think I could keep breaking it down. So I'm going to use this, and this. So that means I'm multiplying all of those numbers together. 2 times 2 times 5 times 3 times 3 to get 180. And then group them up. 2 squared times 3 squared times 5. Pair them up. Put them in pairs. So that means I can split these up. And then 5 is by itself, so lonely. And you can cancel these out. Cross that out. Cross that out. So you get just 2 times 3 times square root of 5. 2 times 3 is 6. Okay. Sometimes when you're like splitting these up, you could also just stop at 9, right? Because we know 9 is a perfect square. So when you see a perfect square, you could just stop there, right? You could just stop there because, right, if I stop there, let's see what happens. 2 times 2 times 5 times 9. And if I split that up, 2 squared times 5 times 9, that's going to look like this. Again, these cancel out. 2 square root of 5. What's square root of 9? It should be 3. So you're going to multiply 2 and 3 again. So you still get the same answer. So if you want to stop at 9, you can stop at 9. But that only works if you stop at a perfect square. But let's just keep going. I think I'm just confusing y'all, right? Just keep breaking it down. Break it down, break it down. Okay? But either one works. Either one works. Either one works. Okay, let's try it again. Let's try it again. Let me try this one with the other method, okay? Let me try this one with the other method. So I'm asking myself, 147 can be broken down into how many different ways? Let's see. 147. No, ignore that. I'm still at school right now. I'm looking at my perfect squares.
So students and staff, if you need to exit at the north gate, please know that it will be closed in 5 minutes. After 5 minutes, you will have to exit at Kincardine and Durango by the staff parking lot. Once again, you will have to exit at the staff parking lot at Durango and Kincardine. Students, you should either be with the authorized adult or headed outside of Hamilton High School. Once again, all students must be with an authorized adult in a supervised area. Thank you and have a lovely weekend.
Me too. Okay. So if we use the other method, right, I'm asking myself, 147, can this number be divided by, where is it? Any of these red numbers, any of these perfect squares, right? And get us a whole number. So let's check. Let me see. 147 divided by, I think 149 might work. It worked out, right? 147 divided by 49 is 3. So I know 3 is a factor here. So 49 times 3 will get you 147. Okay. So again, from there, I could just split them up and it'll get us our answer. Because square root of 49 is 7, right? So I'm going to use that 7 to make sure I get my simplified answer here. So 7 square root 3. So this method is a lot easier, right? It's simple, it's straightforward, but it takes a lot of practice trying to figure out if there's a perfect square or what the perfect square is. This one, it doesn't take a lot of practice. You just need to keep breaking it down and then group them up and you'll get the right answer every time. Okay, but this one just takes a lot of practice. Okay, let's keep going. I'm only going to do one more, okay? Because I don't want to make this video super long. I'm only going to do one more, but I'll post the notes for the rest of them, however you want to solve the problem, right? However you want to solve the problem. You could use either method, but I'll just kind of keep switching off. So let's do this one here. Actually, let's do this one. Yeah, let's do this one. I'll do the other method again. I'll do method 1 again, okay? So I'm going to keep breaking this down. this 5 is here, but let me just ignore that 5 for now. Okay, I'm going to ignore that 5. So let's break down 392. 2 tells me it's an even number, so if I split that up, 2 times, what's 392 divided by 2? 196. I can keep breaking that up. 196. I wonder if I can divide that by 6. No. Can I divide it by 3? No. Can I divide it by... Okay, whatever. Let's just do 2 again. What the heck? So 2, that's going to be 9, 98. All right, keep going. Divided by 2, that's going to be... you know what? Let's do 4. Let's make it bigger. 4. 1. No, 4 is not going to work. What? 3. No, it's going to be 2. It's got to be 2 again. So let me keep breaking it down. See, this is where like you just have to keep going. All right, divided by 2. 49. Okay, now 49 is 7 and 7. All right? So all of the numbers, I'm going to break this down into this. Remember, you could have stopped at 49, but I'm just going to keep going. All right? You could have stopped at 49. Why? 49 is a perfect square. Okay? You could have stopped at 196 because 196 is a perfect square. Right? But whatever. Okay. Anyways, so let's break this down. There's going to be 5. I'm still using the 5, right? I'm still using the 5. And then square root all of these numbers, the circled ones. So it's going to be 2 times 2 times 2 times 7 times 7. So we're only going to put them in pairs, okay? So I see 3 2s. I see 3 2s. So one of the 2s are going to be left out. That's fine. And then I see 2 7s. Yeah, does that make sense? And at some point, you should just be able to do this, right? Just like understand that this is going to cancel out and then this is going to cancel out. So it's just going to be 2. And then one of the 2s is going to still have the square root and then 7, right? But I'm going to, because this is a video, I'm going to take my time. I'm going to break it off. I'm going to break it off. But at some point or soon, you should be able to just see how it just goes away. And then break out each of them. And then they cancel out. And then let's see what happens. Times 2 times square root 2 times 7. 5 times 2 is 10. 10 times 7 is 70. Okay? That's it. Okay. I want to move on to the other page, 9 and 10. So again, the other ones, 7, 8, and 5, I'll post the notes. Like I'll do the problems and I'll post it. And remember, I'm expecting you to write everything down if you want to get it stamped. If you don't have everything down, you're not going to get it stamped. Okay? So it says here, let's explore where the 45, 45, 90 special right triangle comes from, right? Let me just really quickly, let's draw it out. I know that a 45, 45, 90 triangle looks like this, 45 degrees, 45 degrees. These are the legs, leg, and if it's some number x, the hypotenuse is going to be x square root 2. Okay? So it looks like this. And then this is the formula. Hypotenuse equals leg times square root 2. So I kept telling you in class, I'll show you where this square root of 2 comes from, right? So I'm going to talk about it in this video. So let's think about like a square for a second. When we look at a square, all of these angles are right angles, all right? And what happens when you cut a square in half, like diagonally, like that? It's a terrible diagonal. What happens when you cut it in half? What happens is, I'm going to bring out one of the triangles, okay? You start to get, sorry. Also, one thing about a square, we know that all of the sides are the same. So let's just call one side x. Okay, let's make it even easier. Let's call the side 1. Let's say each of the sides are equal to just 1. Okay, let's see what happens. Right, because in a square, all of the sides are exactly the same. So then I'm gonna pull out this part of the square, right? When I pull that out, I'm gonna redraw the triangle. We end up getting a triangle. This is still 90 degrees. This is 1. This is 1. And this angle right here has to be 45 because half of 90, if you cut that in half, if you divide that by 2, you get 45 degrees. So this was 90 degrees, you're cutting it in half, so that's 45, and this is also 45 down here. Okay, let's figure out what this side is going to be. What is this side going to be equal to? Let's call it question mark for now. So if we're trying to solve for that question mark side, we have a right triangle, we have 1, 2, 3 sides here. So let's use our favorite theorem, the Pythagorean theorem. Let's use the Pythagorean theorem here. A squared plus b squared equals c squared. We know a and b, the hypotenuse is always your c. So let's put in question mark for c. And then let's just make sure we put a and b as 1 squared plus 1 squared. Okay. Oh, sorry, it has to be c squared. All right. So 1 squared is just 1. 1 squared is 1 again. Question mark squared. 1 plus 1 is 2. And then we have question mark squared. So how are we going to solve for that question mark, that missing side? We have to get rid of this squared. We're going to square root both sides. All right. And I hope you start to see what's going to come. The question mark is actually equal to square root of 2. Okay, so this missing side is actually square root of 2. So doesn't that look familiar, right? I told you I was going to show you where that square root of 2 comes from. It's this part right here, okay? So when x is 1, right, it's going to look like this, 1 square root of 2. If we said x was going to be 2, then it would be, when you plug it into this formula, when you plug it into the Pythagorean theorem, it's going to come out to this, right? 4 squared, 4 plus 4, and then that's going to be 4 plus 4 is 8, all right? And then what happens? How can you simplify square root of 8? All right, you can split up square root of 8 as square root of 4 times 2, and then the square root of 4 times square root of 2, which turns into 2 square root 2. Right? So then that means the 2 should be in front there. Okay. So this is one way of seeing those formulas come to life. Okay. Does that make sense? So I just gave you one example, but that's kind of where this formula comes from. Let me just plug these numbers back in. Okay. And square root of 2. Okay. That's where that square root of 2 comes from. It comes from a square. Oh, it's funny, square. Right? And that's where this square, it's always going to be square root of 2. So what about the other one? Let's explore where the 30, 60, 90 special right triangle comes from. What about this other one? This one is actually not a square. Let me draw the stuff right now. Hold up. We say this is 60 degrees, 30 degrees, 90, and hypotenuse is always 2x. Short side is always x. And then long side is x square root of 3. Okay. And the formulas are hypotenuse equals short times 2. And then the long leg equals short times root 3. Okay, right, so where does this 2 come from and where does this square root of 3 come from, right? Let's kind of look at that in this problem here. So In this one, we're actually going to explore an equilateral triangle. Okay, so in an equilateral triangle, all of the angles are the same, 60 degrees, and all of the sides are the same. We're going to do the same thing, except I'm going to make the sides equal to 2. Okay, I'm going to make the sides equal to 2. And when that happens, what happens here, I could make all the sides equal to 1 as well, actually. Should I do 1? I'm thinking, should I do 1? Okay, let's just do 1, right? Let's make all the sides equal to 1. It doesn't matter. Well, it'll make sense in a bit. So what I'm going to do is, again, I'm going to cut this triangle in half down the line right there. So I'm going to pull out this side of the triangle. I'm just going to pull out one of the triangles that we get. So if I pull that out, what is it going to look like? Right? You're going to get a perpendicular bisector here. You're cutting it down the middle in half. So that's a 90-degree angle. This is going to be 60 degrees. If you cut this angle in half, that should be 30 degrees. Okay? So does that make sense? 60, 30, and then this missing angle is 90. We already said this side was 1. Okay, that's going to be 1. Oops. Why'd it go away? Okay. So the entire side right here was 1. So if we cut it down in half, this should be 1/2, right? So I'm going to make sure I write 1/2 here. Let's solve for this side. This side is going to be our question mark. Okay, let's solve for that side right there. So what are we going to do? We're going to use our Pythagorean theorem again. Okay, so if we use our Pythagorean theorem, let's see what happens. We know the hypotenuse is C, or this one. So I'm going to plug that in, 1 squared. And then I'm going to plug in question mark squared, and I'm going to plug in 1/2 squared for B. Okay. We actually never squared a fraction, so I'll show you how that works. Question mark squared, we're solving for that. For 1/2 squared, remember, what does it mean to square something? You're multiplying it by itself. So that's just going to be 1/4, right? You're multiplying 1 times 1, 2 times 2, that's 1/4. And then 1 squared is just 1, okay? And then what are you going to do? We're trying to get this by itself. So let's subtract 1/4 on both sides so they cancel out. Kind of stay with me here. I know there's some fractions, but it'll make sense. 1 minus 1/4. When you're subtracting fractions, you should know this. What happens is it turns into 1 is the same thing as 4/4, right? So you want to make sure the denominators are the same. So then this is going to be 3/4, right? And so you have to square root both sides. This is going to cancel out. This is going to cancel out. And your answer is going to be, let me continue the work here. Question mark equals square root of 3/4. Okay. So how does this work out when it's the square root of 3/4? You can actually split up the square root again. Split it up. Square root of 3 over square root of 4. Square root of 4 simplifies to 2. Okay. So your question mark is going to be square root of 3/2. This is actually going to end up being square root of 3/2. Right? So how does this formula, it looks kind of like our formula, a little bit, right? But just a little bit different. Why? What's so different about it? I see the square root of 3 here, and I see a 2 here. But where does this 2 come in? Okay, so what we're going to do is actually, we're just going to multiply. If we multiply all of these sides by 2, we're going to get our formula, right? Times 2, times 2, and then times 2. So then if I redraw my 30, 60, 90, 60 degrees, 90, 30 degrees, the hypotenuse times 2 is 2. 1/2 times 2, that's 1. Oops, actually, let me do it in color. This is green. The 1/2 times 2, that's 1. That's the short leg. And then square root of 3 over 2 times 2, that's just going to be square root of 3. Okay? So that's where these numbers come in. That's square root of 3 in the red, the 2 in the green for the hypotenuse, right? And then if the short side is 1, then everything else is that way. Okay? So everything kind of comes from the Pythagorean theorem. I guess this part was a little bit complicated. This one was a little bit complex. So I just wanted to throw this out there. If you don't write number 9 and number 10, that's okay. Hopefully you're watching this video. I'll even write it here. It's okay if you don't have actually, no, I want you to write this down. Write this down as part of your notes. You don't have to memorize this. I know this is very complicated. I just wanted to show it to you, right? But don't be overwhelmed. This is stuff that'll hopefully make more sense in like algebra 2. This is very like algebra 2 heavy, okay? But okay, hopefully this video helps. Just at least from this video, make sure you know how to simplify square roots and radicals. Okay, this is the most important part. Okay, all right, goodbye.